If you wish, I can share the recording with anybody who wants it. Okay. All right. So good morning and welcome. My name is Christy. I am the Executive Secretary of ESBORG. We are the European Secure Parking Organization, and our goal is just to provide services and security for drivers and make the logistics industry better as a whole. So some of you know us already because you're members, or maybe you've been to one of our other webinars. And one of the services that we provide is for our technical partners. And one of our technical partners is NomadPower. And one of their partners is Volvo Trucks. So they will be presenting today. The workshop today is dedicated to them. And yeah, I'm not going to say too much, but if you have any questions afterwards about ESBORG, NomadPower, Volvo Trucks, you're welcome to contact me or one of our speakers. So again, I want to remind you, just go ahead and turn off your microphones. Pictures are lovely. I love to see your faces, but go ahead and turn off your microphones until you have any questions. And we will take questions at the end. The speakers will let you know when they're ready for questions. You can do that by then raising your hand, turning on your mic, or putting it in the chat, and I'll help field all the questions. Okay, great. So thank you again for participating. And without further ado, I'm going to go ahead and introduce our first speaker. So that's Wijnand van den Brink, and he's the Manager of Special Products and Innovation from Volvo Trucks. So, Wijnand, whenever you are ready, go ahead.
Yeah, thank you very much. I will share my screen. So you will see what it is about today. I'm discussing about electromobility and the situation as it is within Volvo Trucks. I'm myself working now for 4 years with electromobility within Volvo Trucks, and it has been a great journey. And also very nice that I get the opportunity to discuss this in your platform here. But we build the trucks, and what we do need is also the charging infrastructure. And that is not something we are going to do. And we will support our customers, but in the end, we need to support, and we have to do it all together. And the thing together is one of the main words today in my presentation. For those who don't know the Volvo Group, we are a supplier of trucks, but we also are a supplier and builder of buses, construction equipments, and also engines for the shipping industry, as well as the other industrial engines. That is what we are doing around. You will not see the Volvo cars. They are also existing. But Volvo Cars is not a member of the Volvo Group, in spite of they are using still the name, and it is still a Swedish company, and we work together a lot. But the ownership is outside Volvo. And of course, we do a lot of services and financial and insurance and everything around trucks and buses and boating and shipping. We are started the company in 27 by two engineers. And from that point on, quality, safety, and environment, the care for the environment are the 3 pillars we are building up our company. And everything we do, and everything we develop, those 3 issues, those core values, they are made into the products. Quality is a good thing, safety is a good thing, but also the environmental care. And I come back later how we do that. Then the trucking industry is responsible for 7% of the CO2 emissions in Europe. So and that has to be reduced, and there we have to do a big job in the trucking industry as well. So we have put ourselves quite tough targets, and we have said in 2030 8 years from now, we have to reduce 50% of CO2 reduction in our fleet, new sold trucks. In 2040, we want to go back to 100%, and that is to reach the goal in 2050 to be net zero. When you have a lifetime of a truck of about 10 years, that is why in 2050 we want to sell 100% zero emission trucks. Because CO2 footprint back to zero. Then you also see the speed of the development and the speed of the new trucks coming in. And also the necessity to have a good charging network, because those trucks will be battery electric, those will be fuel cell electric, and in some applications it will also be internal combustion engines. They will still exist, but then with carbon neutral fuels. So it is a big change and a big transition which we will face in the coming 10 to 20 years. But we have time to do things, but we have to speed up the process now. And as I told you, it is not only, of course, the trucks and the battery emission, but also building the trucks. Material used for the construction of the trucks. We are now the first truck manufacturer using chassis members of fossil-free steel. We introduced that 2022, but it is more, of course. It is solar energy, it is wind energy used in our production facilities, etc., etc. We are working with that since 2007, and this is the latest innovation we implemented in our production quite recently. The electric trucks and the other trucks will follow. So there you see that we are working with CO2 reduction all over, not just in the users of the trucks, but also the building of the trucks and also demolition of the trucks in the end of their life. End of life is a very important thing for trucks as well. But that is a little bit out of scope of this meeting. How does it look like? So far, until 2020, 2018, we had the fossil fuels, the ordinary diesel fuels. And then we started with LNG as a kind of alternative fuel. And as from now on, bio-LNG is available in the market. We have also started the production of battery electric vehicles, first in the distribution, but later on, and that is from now on, also in regional distribution and also in long haul. So we are expanding our product offering there. And you see fuel cell electric vehicles, what will come in later this decade. I think the second half of this decade, we will introduce the fuel cell electric vehicles. Why is that? The diesel engine, as we know the diesel engine today, it can drive cars, it can drive vans, trucks, buses, vessels. It doesn't matter what you do, a diesel engine is working. And there is no substitute for that. So that means for different applications in future, we will need different solutions for propulsion of the trucks or whatever you want to do. And that is a big change from what we are used to do today. And that is also a big transition where we have to get used to, because all those alternative fuels and electricity and fuel cells, it needs different fuels and also a different fuel infrastructure to fuel all those trucks on the roads. And transportation will not go down, it will go up. That's for sure. So we will see a mix of drivelines and fuels in different segments in about 2030. For refuse, city, regional distribution, and regional haul, it will battery electric. That is what we think about. For long haul and heavy construction, it will be the little bit battery electric, but it will move to fuel cell electric because we need more power, longer ranges, and battery electric is not sufficient for that. And then in the far end, for the heavy construction, heavy haulers, and heavy transports, we still will use internal combustion engines, but with fossil-free fuels and synthetic diesel fuels. So this is how we see the future in about 10 years. What do we offer and what can we get when it comes to electric? About 3 years ago, we started the production of the Volvo FL and the Volvo FE in the distribution segment. The left and the right trucks. And the middle trucks, we will start production after summer. Is it successful? Yes, it is. It are not the big volumes, but so far we have put a lot of trucks in our market. This is the trucks we delivered in the Dutch market, a part of the trucks. So far, and you see it as distribution, and you see it as waste collection, but you also see it as the construction, because the construction segment is very sensitive for CO2 and also the nitrogen emissions. And a lot of the trucks we sold are the cranes with the tippers, as you see in the truck at the right above corner. Half of the trucks is that kind of trucks. Very typical, and that was not what we expected, but in fact it happened, and it works very fine in practice, and we sell a lot. And now we have introduced the heavy trucks. So we have an all-electric range, 5 trucks in Europe, and a special model in the States, where we also go over to electromobility. So in total, we have a range of 6 electric trucks, from 4x2 distribution trucks, 16 tonners, up to the heavy 8x4s for construction work, as you see on the right side, a 4-axle tipper truck, also full electric. We can deliver more or less all our program. And that is, I think, unique for at this moment, that an OEM truck manufacturer can do those things. When it comes to the chassis layout and what can we do and what are the possibilities of those kind of trucks, you see that it is quite full. Normally the fuel tank is, now we have the battery packages. In this case we have 6, 3 on the left-hand side and 3 on the right-hand side, each of 90 kilowatt hours. And of course we can use all the electricity. You see the weight, 500 kilogram per battery, and you have 6, so that means about 3,000 kilos of batteries. Of course you are losing the diesel engine and some other parts, but anyway the truck itself is about 2,500 kilos more heavy in weight than a normal diesel truck. That means less payload. And the EU is compensating 2,000 kilo of that by allowing a higher total mass. But that is not valid for the Dutch market, because we do that as a standard. And I don't know if all European countries have implemented that already. Another thing is that we are assembly the batteries in our own plant in the assembly factory in Ghent. We are working together with Samsung for the battery modules, and they are assembled together in our own production facility in Ghent. And then, of course, always the question is, how far can we come? There is still a range anxiety, still with the drivers. And the Dutch magazine Trucker, they have done a test, and they have found out that the driving distance in these circumstances was 340 kilometers. There's an average speed of 80 kilometers an hour. And you see the route. That means an average energy consumption of 1.1 kilowatt hour per kilometer, which is a very nice result. And we have run tests ourselves with some demo vehicles, and the results were very, very promising in this case. Last week we did an introduction with customers, and it was just stop and go, and speeding up and speeding down. Of course, then your consumption is much higher. But we also did some tests on the highway. And then it comes to charging and charging infrastructure. That's a nice item. I will show you a small video. When we started with the FLRV 3 years ago, 4 years ago, with the selling, we found out that the charging infrastructure was very, very poor. There was hardly any charging possibility on the road. So we decided to deliver a wall box with the trucks, and that could be installed at the home base of the truck. And those kind of trucks, they normally are home at night, so they have possibility to charge it in the home base. It was a 22 kilowatt charger. You see it on the picture here. And in about 8 to 10 hours during nighttime, it is fully charged. And for the FLRV distribution trucks, it was quite a good solution. And most of the trucks, they work with that, and they have a lot of enough energy to do the job during the daytime. And if it was needed, we also could fast charge those kind of trucks. We have an onboard charger, so we can change from the AC charging to the DC charging. And with the DC charging, we can go up to 150 kilowatts. And I know 2 or 3 customers doing this regularly in the Amsterdam area. And that works quite fine. And then you can charge within an hour or so. Normally, they start charging during lunchtime. And then you charge for an hour, and then you have enough energy taken in to do their job for the rest of the day. That works quite good. But now we are going over to also introduce and sell and deliver the FM and FH trucks, the heavy duty trucks, with the 40 tonners or 44 ton, or in the Netherlands we even might go up to 50 tons. That is our goal. And then we need more energy. With the heavy duty batteries, we have 2 possibilities, 450 kilowatt hour or 540 kilowatt hours. That needs more power. And for AC charging, overnight charging, we need 43 kilowatts. That means we need 63 ampere in the connection. And with overnight charging, in that case also, we charge the trucks in about 10 hours. And then it is the interesting part, because those kind of trucks, a lot are at the home base during night, but not all. There will trucks being out on the roads and has to find a public charging opportunity to be charged during the nighttime and find their energy somewhere in a public charger. And they also can do the fast charging. And that's interesting for those who are running in 2 shifts. For instance, when we do the big stores like the Albert Heijns and the Jumbo's in the Netherlands, the big superstores, those kind of trucks, they run in 2 shifts. And they have to fast charge in between, because elsewise they won't have enough energy to come to the end of the day. And then you need the 250 kilowatt fast charges, so they can charge within an hour or 1.5 hours from 0 to 80%. But what we have found so far is trucks are not down to 0%. Normally, when you're back to 20%, the driver wants to charge, and he doesn't always have to go on to 80% again. So we can do, in practice, he can do a lot, and we have done a lot of simulations as well. I come back later in my presentation how we do those kinds of simulation with the routes and the route calculation. Also, the heavy trucks, they can charge with AC charging, and they can do the DC charging. The trucks have the onboard chargers, so they can receive both AC and DC current. And that's a big advantage. But we also tell there are a lot of sorry, this is in Dutch to see. There are a lot of factors influencing the driving distance still. That is the temperature. Outside temperature is very important. You know, when it is below 0, the capacity of the batteries is going down. But we are heating up the batteries. Also during the charging, we are heating up the batteries and preconditioning them so they are ready to run. Of course, the load is important. The more load you have, the more energy you will use. That is a logical point, I think. Average speed is important, but on the Dutch highways, the average speed is about 83, 84 kilometers an hour, and for electric trucks, that is very nice. But when you go abroad, speed might go up. The right tire choice is important. Rolling resistance is an important thing. Of course, the batteries are, when they are becoming older, they lose their capacity a little bit. What we do is we say when the capacity is down to about 80%, we have to exchange them, and we offer the trucks with repair and maintenance contracts, and also with the battery coverage in that. So it is not the risk of the customer, and here's no big surprises. But the most important is the driver performance. The driver is one of the most influencing parts on energy consumption. It can go up to 20%. And for those who are interested, I've put the percentages here so you can study afterwards. Of course, the route is important. Where do you start and where do you end, and can you make your trip? And where do we have to charge on the way home? So what I did made an example, starting in the Rotterdam harbor, going to Duisburg, which is a trip which is used a lot in a lot of people running with the containers, etc., just to see what you can do with an electric truck. And as you see, you can make this trip without charging on the way. This is a trip, you see it, 258 kilometers, and you can manage with a 20 feet container with 20 tons, you can manage to do so. Then you have to charge your truck, of course, and when you go, for instance, back to Rotterdam, but you first have to do a drop in Antwerp. Of course, then you have to charge, and you see what is happening in the. Here you see you cannot come back. So when you are in Antwerp, you have to charge as well to come back and end your trip. And we can do that calculation with different temperatures. The typical temperature is 15 degrees, but when it is freezing, you see the effect. And when it is very hot, you also see the effects. But about 30 degrees Celsius is no problem, but when it comes to 35, 40, then you have more or less the same problem which you have when it is freezing. So in very hot and very cold circumstances, your capacity of your battery is going down. And in this way, we can plan the trip with our customers, and this is also available for the customers. So they can guess themselves if the driver can do the trip, yes or no, and find a charging spot. So there will be a big need for charging stations in Europe when it comes to more, where we increase the number of electric trucks, and there will be more on the roads. They will have to be charged. ASEA, that is the organization for truck and car manufacturers. They've written a big report, a very good report about the charging needs in future. So you have to go through it if you are interested in that. And for trucks, I made a thing. There are 24,000 public charging points needed along the 10T corridors. It's a lot of charging points, and ASEA is pushing for that in Brussels as well. Just one picture from the ASEA report to see what is happening, what they find in their study, and that comes with our experience as well. When it comes to urban trucks and distribution, they don't need the public charging that much because they are in their home base during nighttime. For regional trucks, it's a little bit more, but still, they are a lot in their home base. But for the long-haul trucks, which we have introduced now, it will change, and 10% of those long-haul trucks will need a public overnight charging, and 50% will use the public charging during the daytimes. because otherwise they cannot make the trip. Like the trip I showed you from Rotterdam to Duisburg to Antwerp, back to Rotterdam. It's more or less 1 day trip, but you need at least 2 charging points in between to make that trip in a 1 day period. Otherwise you cannot manage. So in here it gives a lot of opportunities when it comes to charging, but then I leave the screen to Hans, because he will tell a little bit about the plans they have. But you see the needs, and when it comes to trucks, we are clear. We are ready for the future generations. We have to care for them, and for those who have children or even grandchildren, they all know we want to give them a lucky life as well. So maybe there are some questions. I think there is time for a few questions, or do we take them on the far end? Or?
We can take a couple questions. I see Eric has his hand raised. If you want to go ahead and unmute yourself, you're welcome to ask a question.
Okay, thank you. My name is Erik Roefs, province of Limburg in the Netherlands. I have a general question, and that is in Volvo's vision no important role for hydrogen AGVs?
Hydrogen is the fuel cell electric. Yes, we have a program running to introduce those, but they will come later. First, we start with the battery electric, and the fuel cell electric it's also an electric vehicle, but energy is not coming from the batteries, but from the fuel cell. So from technical point of view, you add something to a battery electrical vehicle, and that makes it more complex. And also the production of fuel cells in big scale is not that easy. So we are working with that, in fact, with a joint venture with Daimler Trucks. It's called Cellcentric, and we will introduce those kind of trucks in the second half of this decade.
Okay, and Nico Fernandez, I see you have your hand raised if you want to go ahead and ask your question.
Yes, good morning, everybody, and thanks, Mr. Van den Brink, for sharing this. This is Eneko Fernandez from Thermokin and Frigoblock. First of all, thanks for using a truck with a refrigeration unit in one of your early slides there. Yep. Good to show this partnership. Mr. Van den Brink, I have a quick question on the technology share graph you showed, battery electric trucks, fossil-free internal combustion engines and fuel cells. I have a question if you could share what potential fossil-free fuel combustion engine technology you foresee for the future. What would that be? Are you talking about hydrogen ICE trucks or anything else?
It might be the diesel truck with but with HVO or all the kind of e-fuels, and also the hydrogen ICE truck is also an opportunity. There are a lot of technical solutions to solve the problem, but it is far too early to tell exactly what Volvo will have in future. There are a lot of development programs running now, and there are tests going on, and we simply don't know what choice we will make in the far end.
Okay.
But it's likely that we start with the internal combustion engine, but with the e-fuels like we have them now.
So biodiesel fuel could be part of this category, for example?
Yeah, biodiesel can be a part of HVO, is something that is available already today on the market. To reduce the CO2 emissions, and in the Netherlands it is not so generally used, it is too expensive. But in some other countries, especially in the north, it is a very popular fuel. Yeah.
Okay, thanks a lot.
Yeah.
Okay, and I see in the chat we have a question from Ferdi Ikink. Are the truck companies working together so that they use the same electric plug for charging?
Yes, the charging will be the CCS Combo 2 charging system, and that is more or less an agreement made by ASEA. So that is the common charging plug that is more or less standardized. You don't need different types of trucks for different types of trucks. And that's good. And in the future, we will go over to the mega charging system. And they will have a different plug because of the capacity. But also they are working on a standardization program there as well. That's absolutely a must. Yeah, we realize that.
Okay, are there any other questions before we move on to Hans' part of the presentation? No? All right, then I just want to thank you, Wijnand. It was a really interesting presentation. I think e-mobility and sustainability are obviously big on the logistic industry's agenda right now. We see it also with the Commission. We actually also just had a meeting with ASEA, so it's definitely very pertinent. And of course, to supply that, we need infrastructure. And we've seen NomadPower has helped a lot of our members already with charging infrastructure. So I will let their CEO, Hans Beuvers, now explain a little bit. And again, at the end of his presentation, if you guys have questions, we'll do it at the end. Okay, take it away, Hans.
Thanks so much, Christy. Good morning, all, and thanks for joining this morning. Also, thanks to Wijnand for the update about the latest e-mobility developments at one of the largest truck OEMs. There's a lot going on. As said, I would like to tell a little bit more in the next 20 minutes about the specifics of commercial charging solutions, and then in particular the charging infrastructure needed at truck parkings and logistic centers.
Hans, you still on mute.
Yes.
Oh, I mute myself. Sorry, I tried to go from page 1 to 2. You can hear me now? Do you hear me?
Now we hear you, yeah.
Yeah, perfect. No, I was just mentioning the why is it important, the electrification of trucks. So what we, and this is an interesting quote, it is basically saying that trucks account for less than 2% of all the vehicles, but 22% of the CO2 emissions. So if you're a policymaker and read this, then you're like, okay, this is an interesting opportunity. Because although it might be challenging, if I manage to deal with that 2% of all the vehicles, I managed to reduce 22% of the CO2 emissions. In general, it's not, of course, that the trucks are that polluting. It's just the sheer mileage they do on the road, which causes this sort of high emission of harmful CO2. And that's sort of the challenge where we are at the moment. If I look at the seem to have a problem with getting to the next slide somehow. Oh yeah, here we are. So if I look at charging at truck parks, there are two charging needs. There's one for refrigeration trailers that is very much based on an existing demand for cool trailers, which are already equipped to use electricity while parked up overnight. And then there's a future demand for electric trucks, which will come over the next years. So if I spend a bit of time on the refrigeration trailers, and that's also the network NomadPower has already built in across Europe. then we see that this should actually be a relatively easy transition. So we're talking about 15% of all the road transport and all the road transport are refrigeration trailers. And all those refrigeration trailers are sort of equipped with so-called transport refrigeration units. In fact, large fridges, quite sophisticated fridges, probably Thermo King and Carrier. If when they're on the call, they'll probably correct me. But in fact, they have an electric engine, but they are not using any batteries or direct links with the truck, but they are simply powered by an auxiliary diesel generator. But they can also simply operate using electric power, and especially when they're parked up at night at the truck stop, it would be a relatively simple solution without any modifications on the trailer to plug in and to use much cleaner, quiet, but also cheaper way of powering the TRU. And if we look at the emission levels, because of the auxiliary engines are relatively old-fashioned, you can save up to 10 tons CO2 per trailer per year. So that is sort of a first step which we have been involved with. If you look a little bit ahead, then obviously this polluting and noisy diesel generator will ultimately need to go. And the larger trailer and cool unit OEMs are busy now how they create a so-called engineless cooling trailer. And that will be a combination between kinetic energy technology, so power generated from braking and drive shaft while on the road, while moving. But also adding batteries for short stops, and then finally also combine that with charging infrastructure, so they can sort of charge the battery while at stops and overnight, but also provide direct power to the fridge unit, which need to operate at night as well. So that is sort of where this is going, and that's also a particular need at truck stops to provide those electricity at the truck stop for the cool units. And NomadPower is very much positioning ourselves, and we have positioning ourselves as of charging solution towards the zero emission refrigeration transport. To give that a little bit more body, it's probably good to show you a short video of one of the clients using the system, so that shows you a little bit better what's going on. So hopefully that showed a bit how the system works, and also what is needed to successfully operate a system like that, whether it's for refrigeration trailers or for truck charging, because by definition, long haul is an international business. So the use of an app and the technology behind it is really important. So the initial network we built is sort of in 9 different countries, and we're constantly working to extend the network. Let's quickly move to the e-truck charging, and couple of slides, and I think we touched upon that already. There's of course a bit of discussion going on. Okay, are we going to electrify, or are we having the fuel cells, hydrogen solutions? I think, to be honest, I feel very much like the up to the truck and even the long haul business is going to be electric. And why I'm saying that, if you look at the efficiency rates for direct electrification and hydrogen, and then we're not even talking about the infrastructure needed, but the direct electrification is much more efficient as a form than hydrogen. So if you talk about certain transport and you can electrify them, then you probably will over hydrogen. And that's what we're looking at. And of course, I think the long haul might be a little bit on the cusp between electrification and hydrogen, but I still think with the market forces which are going on now, also long haul will be an electrified business. Also to see that, it's that you see what Volvo just explained. There's an awful lot of new introductions of e-truck models, which will be relatively easy ultimately to provide longer range. So the range extension of those trucks will sort of increase every year. The Volvo trucks here mentioned are the typical 200, 300 kilometer range. Now Wijnand was talking about 400, 450 kilometers. And probably next year we'll talk about longer range extension. So ultimately, battery technology will increase, and the range extension will be enough to cover most of also the long haul transport. There's of course the total cost of ownership is important, and there you see that the urban haulage will be reach TCO parity earlier than the regional and the long haul transport. But also I still think by the development of the truck, it will be relatively quick for the long haul also to offer TCO parity, but it will be later than the urban and the regional ones. A couple of things about the demand for truck charging, and some people I think underestimate that, what type of demand is needed to provide truck charging. This is a report done by ILAT, an organization in the Netherlands. And if you look at the electricity demand in terawatt hours on the right hand side, and then you're talking about this 2035, you're talking about 6 terawatt hour for trucks in inner distribution and international, compared to 7.8 terawatt hours per year for cars. So the whole truck market is in effect 80% of the EV car charging market. And that is quite substantial, of course. And also the number of trucks will increase dramatically, I think, over the next years. We talk about 50,000 large trucks in the Netherlands alone in 2035. Wijnand alluded already to this, to the report by ASEA, and also the EU EV Charging Master Plan, detailing the number of charging points needed over in 2025 and 2030. So you're really seeing it going up exponentially. going from 37,000 to something like 279,000 in 2030. I think it's fair to say that the initial demand will be within the fleet hubs. And it's a graph Wijnand showed as well. You see clearly that the urban trucks, the regional ones, are basically charging at their own hub. But if you're looking at the long haul, and that is sort of the importance here for the truck stops and the logistics centers, we're really looking at a substantial amount of charging which needs to be done away from home. Actually, 60% out of 100, 60%. So that is sort of regarding the demand. A couple of points, and I think that's of interest because the trucks now are charging at their own depot. They're charging at their own depot, but what is the role of the truck parks in the future for charging? I think a couple of aspects here. First of all, we just saw there's a large electricity demand needed to charge the trucks. So for sure there will be electricity grid constraints, but there also will be various discussion on the type of charging you need. Will you only need extreme ultra-fast DC charging, or will there be a combined model where you see overnight AC charging with a bit of DC charging and also then opportunity charging, which will be highly fast DC charging? So that's one of the discussion. The second discussion is that different from cars, then you can't really park your truck in everywhere. So it's quite limited where you can park your truck. And all the members of SPARK will know that the shortage of parking bays is quite substantial. And we talk about 100,000 bays shortage within European Union. So you have a limited possibility where you can charge, where you can park. And it's also not easy to create additional parking bays for trucks. So I think that is really important to understand. And the third factor is that the transport sector will demand as little change in logistical flows as possible. So they will probably say like, okay, can we use existing logistical flows and use existing parking infrastructure here? And then there's another part which will be important for the public charging, is that charging and parking will be interconnected. You will need a parking bay to charge, and that sounds quite obvious, but it actually brings quite some consequences with it. Ultimately, you also need to give guarantees that you can charge, and therefore also you need to give guarantees for the parking. So there will be more and more need to ultimately have a book park charge type of concept to successfully operate public truck charging. And that's, I think, where also the truck park operators will need to take the next steps. Because ultimately, to successfully really offer public overnight charging infrastructure, there will be a book park charge element here. So transport companies will need to be able to book parking and charging. There will be a need for individual parking bay reservations instead of like access to a parking. Yeah, but most reservations at truck parks are currently based on giving you access to the parking and not necessarily having a right to park at an individual bay. But for charging, that is quite essential. If you look at the parking, what I mentioned before, there's not going to be without parking, no charging. So the two are sort of really linked. And and there need to be then very specific parking and charging infrastructure, and the bays need to be kept available, which is not always the case. The whole parking management differs quite a lot from parking to parking. And then I will come to that in the next slides. You will offer quite various type of charging. So you can offer overnight charging, but also DC charging. And you need to be flexible and build the different blocks going forward. So how we look at the charging infrastructure setup, the NomadPower network is very much the first bit. It's the overnight refrigeration trailer charging. So these are the industrial plugs. So they're slightly different from the charging ones. It is really focused on reduction emission and noise disturbance. And if you look at the type of grid connection needed, you need about 240 amp or 180 kVA to operate 12 sockets. This is sort of a first step, I reckon, for most truck park operators regarding charging infrastructure. And it is also going to be mandatory within the EU Safe and Secure Truck Parking Standard by the end of 2024. What we are doing now is the second step, and that's we are now equipping the first locations, and that's also an interesting part. What Wijnand was saying, the fact that the new Volvo trucks can also use AC charging as well as DC charging. So if you charge overnight 43 kilowatts for 10 hours, you are fully charged. So what we are combining at a relatively low cost is that we are combining Frigo and e-truck charging at one pedestal. So we're offering both Frigo charging as 43 kilowatt AC charging for overnight. And then you could also combine that ultimately with some opportunity charging of light commercial vehicles, which might visit the restaurant during the day. And that's sort of, I think, quite a logic second step for charging infrastructure. If you then go to the DC charging, then you could do several things. You could say like, okay, I have a nighttime overnight AC charging business, but during the day nobody's using it. So why not use my complete capacity I have for DC charging during the day? And so you could sort of combine your 240 amp, the 180 kVA, or even more, depending on the numbers of chargers you have for nighttime charging. Combine that into one or two DC chargers, which will be able for people to use during the day. And there you will optimize the usage of your capacity on site. Probably for that you will need a parking and reservation system, because people, it will be just in time when they arrive at the parking. They don't have much time during the day, so they will be most efficient in their usage. And there might be a possibility here to also combine that with EV car charging, and that very much depends on the layout of your parking. And then, of course, there is the overnight DC truck charging. So I'm not talking about forecourt business here. I'm really talking about the truck parks, where ultimately capacities of 150, 200 kilowatt DC charging will be enough for charging the trucks overnight. And for that, again, you need a parking and reservation system. Obviously, we have done a lot of parkings. We have 60 parkings across 9 European countries. So we have a lot of experience in how to do this and how to start with building this infrastructure. We are combining hardware and software, clearly. And so there's a whole operating system. It's a complete self-service system, as you saw in the video. And we are, as NomadPower and the company behind it, are now also operating this whole book park charge element. So that's sort of what we are currently are offering, and I guess I'm a bit conscious of time as well. I think we just at the end here. Maybe last thing is that we're also going to visit the Connecting Europe Days next week. So if anyone there, I'm happy to be there as well and answer any questions you might have.
Thank you, Hans. That was a really good, interesting presentation. It fit in super well. And like Hans said, next week is the Connecting Europe Days, used to be called the 10T Days. They will be there, we will be there. So feel free to come see us. Are there any questions about Hans's presentation? I saw the chat was a little busy, but I think you guys were talking to each other. If there's something that didn't get answered, feel free to bring it up. Okay. No?
Oh, I see some hands.
Oh, there they are. Sorry. Okay, Brian, go ahead and you can ask your question.
Good morning. Good morning, Hans.
Hi, good morning.
I put a question in the chat there. Already there's significant capacity issues for charging cars and small vans and vehicles in the UK. What are the plans for the future to put in the infrastructure in place to meet the future demands for charging trucks? Already the network in the UK is not meeting the capacity that's required. Have you been in discussion with the National Grid and the DNOs to discuss the future needs for this?
Yes, we had some discussions with them. Obviously, it's always not that straightforward and easy to do grid upgrades, and will be one of the main challenges. And therefore, also I think that it is probably one of the reasons why parking and charging, and therefore having longer time to charge your truck, will be a really interesting proposition, because I think the National Grid and the DNOs are really struggling with the high capacity they need to deliver at one specific location. If you can sort of unlock lots of charging locations and combine it with parking and charging for longer periods, you don't necessarily need to have the higher the capacity. And I think that is sort of where we really need to look into, is that how can we most efficiently use the grid capacity? And that's one of the examples I used as well. Can you combine a certain concept you have for overnight charging with a demand there will be for daytime charging, and how do you make sure that that is sort of done in the most efficient way?
Okay, thank you. And I see Julia, you have a question too. Go ahead whenever you're ready.
Yes, thank you. Good morning, all. Julia Williams from Hydro Consult and Partners in the Netherlands. Actually, I have two questions. The one is a follow-up question to Wijnand. I would be very curious to know, we discussed a little bit in the chat, but I would be very curious to know what the actual energy performance development of electric trucks has been over the past years. Because if you look at the discussion we have here now about the tremendous amounts of energy needed to power all the trucks in future, any gain, of course, is any gain in efficiency is gain in sustainability. So if there is any information available or any source you can point me to, Wijnand, that would be I would be very grateful. My other question is for Hans, but maybe first we should.
Yes, I can react. We started the production of FLRV 3 years ago, so there is a quite short period of time. We have made quite small improvements in the technique, but to be honest, I don't know the effect on efficiency in figures. What we did, we started with 50 kilowatt batteries. We increased the capacity of the batteries to 66 kilowatt, and we will increase it later this year to 94 kilowatt. So there you see a big increase, close by double the capacity of the batteries. And that means that the driving range is also much higher, which is also needed and asked for by our customers. Those are the biggest steps for the moment.
Okay, thank you very much. My question for Hans is, we just discussed the situation at parking lots and the lack of availability of power to charge everything. What is your company doing when it comes to solutions like stationary storage batteries to ensure that you can deliver higher power compared to your grid connection? Does it play a role in your work?
Not directly, but indirectly we had a couple of conversations. So we have one location, for example, where they are using a solar roof for the at the parking, and that is also beneficial, especially in the southern part of Europe, for drivers to basically to be in the shade. But obviously there is a lot of electricity. But there are a couple of things here. Is that what we have seen in practice is that obviously for our model, most of the electricity demand is at night, while solar electricity is created during the day, obviously, and there's a mismatch there. And we have seen, and that might change, is that some of the projects we looked at, that it is actually quite expensive to do a battery storage to make that conversion between day and night. So in the project where what we looked at, they basically just provide it back to the grid, and then they take it at night again. But I see more and more projects, especially also at logistics centers, where they use these battery containers, and they're trying to bridge the mismatch in the electricity demand and supply. So I think it will play a bigger role going forward, but it's still a little bit, not every project has the business rationale for it, or it's too expensive to use the containers.
Okay, thank you very much. I suppose that will change in future. I mean,
I think so as well. Yeah. So and that could of course be interesting, because then you can sort of the whole management and of it is going to be hugely important. And that's also I'm trying to do that by saying, like, okay, instead of charging in 45 minutes, you can also take the opportunity to charge overnight in 10 hours. That's basically the same as having it all in one battery and then taking it out. So we're trying it in all kinds of different ways to stabilize that.
May I ask another follow-up question, please, Christy?
If you make it really quick, because we're over time, go ahead.
Very quick one. Do you use energy management systems, Hans, on your on the parking areas where more than one vehicle is charging at the same time?
Yeah, we're looking at that, but you have to see that there's a difference between a lot of our business is still for the refrigeration trailers, and that's a direct power supply. So I can't really manage that. They ask, we need to deliver. If you charge batteries, then of course you come into the charging management, and that of course we're going to use, and we are taking and we are working on that particular bit.
Okay. Thanks a million, and sorry to take us all over time.
No, it's okay. I'm sorry that we have to cut it off. We are a bit over time, so maybe we can always have a follow-up webinar too in the future. But if anyone does have more questions, feel free to email me, or if you want to get in contact directly with Wijnand or Hans, feel free to let me know and I will put you in direct contact, okay? And thank you all so much for participating. I think it was extremely illuminating, and thank you very much to Maynard and Hans, our presenters. Have a good day, and like I said, if you have more questions or you need anything, let us know. Okay? Thank you so much.
Excellent. Thanks so much.
Thank you.
Yeah,
Thanks
thank you
for
very
the
much.
Thank you very much.
Thank you.
Bye.
Bye-bye.
Bye-bye.